Alright, so this is section 1-7, absolute value inequalities. And this section is actually probably one of the tougher ones in Chapter 1. And so, to kind of set the stage in the first part of this lesson, I want to talk about a somewhat real-life example of a baseball. And that's going to help, I think, understand the problems that we have to do. So, in professional baseball, the perfect weight for a baseball is 5.125 ounces. That's the gold standard. That's what we want. Odds are, though, our baseball is not going to be exactly that. When we manufacture it, things just aren't going to be perfect. And so we're allowed to have a tolerance of 0.125 ounces. And that means one of two things. That means that my baseball might be too heavy. How heavy? Well, at most, here's my perfect baseball, 5.125. I could be heavier by my tolerance, 0.125. And if we do the math and we add those two numbers together, we would end up with a maximum weight of 5.250. That is the heaviest possible baseball I could have. But on the other side, my baseball could be too light. And so again, perfect baseball, 5.125, but I could minus be too light by 0.125 ounces. And in this case, if we do the math, I would be exactly at 5 ounces. So the heaviest possible legal baseball I could have is 5.250, and the lightest legal possible baseball I could have is 5.000, which anything beyond that or outside of that realm would be not playable. So one way to represent this mathematically is using an absolute value. So something like this. W minus 5.125 is less than or equal to 0.125, my tolerance. Now this requires a little explanation. So W, let's say W is a baseball that I have. So we'll call that my ball. Okay, now my ball, I would love for it to be the perfect weight, 5.125, but odds are it's not. 5.125, however, is the perfect weight. That's the perfect ball. And by subtracting those two numbers, what I'm coming up with is how far am I off? How far am I off? And let me put some numbers to that to explain it. Let's say I have a baseball that's a little bit too light. So my ball is 5.120 ounces. Now take away the perfect baseball, and again we can do the math, but you'll find that I am 0.005 ounces too light. Likewise, and maybe I have another ball, maybe I'm too heavy. So maybe that ball is 5.130. Again, take away the perfect ball, 5.125, and I find that I am 0.005 ounces too heavy. So what this is telling me is how far off am I? And my concern is that I want to make sure I am less than or equal to 0.125 off. So I can't be off more than that or I have an illegal baseball. So then the question is, what's the absolute value do? Well, remember the absolute value says, I want to know how far away I am from zero, and absolute values are always positive. So I don't care if I'm too light or if I'm too heavy, I just don't want to be more than 0.125 off. And let's see how that plays out with the numbers. So absolute value here, and that, the absolute value of a negative number is a positive number, and the absolute value of a positive number is still a positive number. So both of these problems, both of these balls, one is too heavy, or sorry, one is too light, one is too heavy, but I don't care about that. All I care is how far away am I from my perfect ball. And in both cases, it's 0.005. And in both cases, I'm okay. I have a legal baseball. In both cases, this number here is less than 0.125. So I don't care if I'm too light or too heavy, and that's how the absolute value helps me to capture that by saying, hey, we just want to know how far off we are. We don't care if it's to the negative side or positive side. So in the next part of this lesson, we'll actually use this idea to dive into some problems. And my goal is to figure out how can I actually solve inequality problems like this.